Hello and welcome back to math class. Let's continue with applications of maxima and minima. This would be word problems that involve maximums and minimums of quadratic functions. Here's an example. The student council plans to run the annual talent show to raise money for charity. Last year, tickets sold for $11 each and 400 people attended. And the Students' Council has decided to raise the price for this year's talent show. They've determined that for every dollar increase, the talent show attendance would decrease by 20 people. I guess 20 people would say, it's getting a little too expensive for me. I don't think I'll go this year. So every time they raise the price a dollar, 20 less people come. What ticket price would maximize the revenue? Now, I've underlined the word revenue here because this question involves maximizing revenue, not profit. Revenue is money that comes into a business. Solution. Let X represent the number of price changes. That's how you handle this type of question. You let X represent the number of $1 increase. The number of price changes, not the total price change, not the new price. X represents the number of times you changed the price. Then we can say revenue that comes into any business is the number of customers multiplied by the price that they pay. And a good example of this is the TTC, the Toronto Transit Company. Every time a customer walks through the turnstile, they drop in the fee or the fare, and at the end of the day, if you want to know how much money there is in the turnstile, it's the number of people who came through multiplied by the price that they paid. Customers times price. This is where money comes from into a business. Now, we can say that the number of customers here, well, it's 400 customers. 400 people attend. That's why there's the number 400 there. But it's going down because fewer people are going to come. In fact, 20 fewer for every time we change the price. That's what the survey said. So the number of customers is 400 take away 20x, where x represents the number of price changes. Meanwhile, the price is currently at $11, and it's going up. So it will be 11 plus the number of price changes multiplied by the $1. So this is what the price is. We can see it's lined up here. Price is 11, but it's plus 1 for every x, or 1x, or just x. Now we have an expression that involves the revenue that's coming in for the student council. And now it's just a matter of doing the math. The setup is the entire issue here. Multiplying it out, completing the square by factoring out the coefficient, which left a 9 here. We're checking our work, minus 20x squared plus 180x. Take the 9, cut it in half, make it 9 over 2, square that, 81 over 4, add it and subtract it, completing the square. Multiplying across here to remove the fourth term. Now let's think about this. 20 is going to be multiplied by this term. So it's going to join the numerator as a factor. It will be 20 over 4, which is 5. And 5 times 81 is 405. And so when it comes out, it will be plus 405 because it's a negative times a negative. So it's a plus 405. Plus 4,400 will be 4,805. Meanwhile, we can repackage the square. X minus the square root of 81 over 4 is 9 over 2. From here, using this as a model, here we have vertex form for a parabola, the general case, where k, the y value at the vertex, is associated with y, because k is y at the vertex. So that this number here, 4805 will be associated with R of X. So this will be the highest revenue they can get, 4805. Meanwhile, that happens when X is positive 9 over 2. So when X equals 4.5, that's 9 divided by 2, we have our maximum revenue, $4,805. And the price that we charge the customers, let's look here. It says the word price in our math work, and just below it we have 11 plus X. But X is 4.5, so it's 11 plus 4.5, and that's, here it is, 11 plus 4.5, or 450. $15.50 is the price that the Students' Council should charge to maximize the revenue. Moving on, let's do another example. This one's about profit. Businesses are interested in how much money comes in, sure, that's called revenue, but they're more interested in profit. So find the X value that maximizes the profit function and the maximum profit. If we know that the revenue function is negative 2x squared plus 30x, and the cost function is 14x plus 30. Any person who's ever run a lemonade stand in the summer understands that profit, the money that they get to keep, is equal to the revenue, the money that came in from selling the lemonade, subtract the cost, because they had to go to the grocery store and actually buy the lemonade. So the profit involved is the revenue, the money that came in, take away the costs. And we use that. It's basic common sense knowledge that everybody has. Solution. The profit is the revenue, take away the cost. And so we'll just simply express the revenue which was given, and then subtract, and then put in brackets the cost which was also given. Expand and simplify, collect like terms, and then complete the square, which means factor out the coefficient minus 2, this minus 2. And when you do, you get x squared minus 8x. Let's check our work. Minus 2x squared looks good. And minus times a minus is a plus 16x. That looks good. And now we have to take the coefficient that we see here, the 8. Divide it by 2, square it, add it, and subtract it. Again, we take the coefficient on the x, cut it in half, square it, add it, subtract it. Well, when you cut it in half, you get 4. When you square that, you get 16. So we go plus 16 minus 16 to find the vertex. And then when this minus 16 steps out, it's multiplied by minus 2. That's why it says positive 32, because 16 times 2 is 32. We can repackage this square here as x minus 4 squared, and meanwhile 32 minus 30 is 2. And we can check our work. Squaring a binomial, x squared, double the product, so that's minus 8x, and then plus the square of 4, which is 16. And we can make this statement. The x value that maximizes profit is 4, x at the vertex. And the maximum profit itself is the y value at the vertex, which is 2. Let's do another one. Maria produces and sells shell necklaces. The material for each necklace costs her $4. So she doesn't get these things for free. She has to get material and make a necklace. And it costs her to make a necklace, $4. She has been selling them for $8 each, and she's been averaging sales of 40 sales a week. She's been told that she could charge more, but has found that for every time she raises her price by 50 cents, she loses 4 sales out of those 40. The question is, what selling price should she set? And what would her profit per work be at this new price? Okay, solution. Again, let X represent the number of price changes, not the new price, not the revenue. X represents the number of price changes, in this case 50-cent price increases. Profit is revenue minus cost. And revenue comes from customers who pay a price. Remember this, revenue is customers times price. Meanwhile, cost, in this case, is $4 for every customer. So we'll subtract cost, we'll subtract 4 times the number of customers. And we're building an expression. The number of customers, for example, look into the paragraph, there's 40 in a week, but she's losing 4 every time she changes the price. So this customers will become 40 take away 4x. Meanwhile, the price is going up. Currently, the price is at $8, but it's going up. That's why this says 8 plus. Underneath price, we have 8, but it's going up by 50 cents for every X. That's where all of this comes from. Now, let's look at this. Customers here, customers here. If this says 40 minus 4X, then this must say 40 minus 4X because they both represent customers. Multiplying it all out, collecting up the like terms, common factoring out the coefficient, checking our work, minus 2x squared looks good, plus 4x looks good. Take this coefficient, divide it by 2, square it, add it, subtract it. So divide it by 2, you get 1, square it is 1, add it, subtract it. The minus 1 here steps outside the brackets and becomes a plus because it's multiplied by this minus 2. Repackage the square. Check your work. X squared, double the product is minus 2x plus 1 squared. Looks good. And we have our vertex. Change the sign, leave the sign, so it's 162. And we can see that X at the vertex is the number 1. So only one price increase, because when we look back at this let statement, X represents the number of price increases, and that's 1 at the vertex. Therefore, the maximum profit is the Y value at the vertex, $162, when there is just one price increase of 50 cents to a new price of $8.50 per necklace. A last example, a rancher, a farmer, has a 135 kilogram steer, and this steer is gaining weight as he feeds it. It's gaining weight at the rate of 3.5 kilograms a day. But it costs him to feed it, it costs him 80 cents a day to keep this steer on his ranch. The market price for beef, cattle, is $1.65 a kilogram. But the price is falling by 1 cent a day. When should the steer be sold to maximize profit? And that's the key word here, profit. And you might say, well, we're talking about cents, just a few pennies here and a few pennies there. Who cares? Well, it doesn't really matter unless you happen to have, say, 20,000 head of cattle or something, in which case it does matter. Solution. Let X represent the number of days to wait, which is the same as let X represent the number of price changes, because there's a price change every day. Profit is revenue take away cost. Revenue, where this rancher is going to get money, it will come from him selling kilograms at a certain price. So it will be the number of kilograms that he can sell multiplied by the price per kilogram. Take away 80 cents a day, because X represents the number of days to wait, and he has to feed this animal, so it's 80 cents a day. Now the number of kilograms is currently 135. It's 135 kilogram steer. But it's gaining weight. 3.5 kilograms a day. So kilograms will become 135 plus 3.5x. Meanwhile, the price per kilogram is currently $1.65, but it's going down by a cent a day. So the price in this bracket is the same as the price in this bracket. It's $1.65 per kilogram, but it's going down. That's why you see a subtraction sign by 1 cent a day. X represents the number of days to wait. Meanwhile, 0.8x has been brought along, carried forward. We now have an expression for profit, and all we need to do is find the vertex by multiplying it out, collecting like terms. I haven't shown all that, but I suggest that you take a piece of paper and multiply out this expression, collect like terms, and confirm the truth of what I've written here. Factor out the coefficient. Take this coefficient on x, cut it in half, square it, add it, subtract it. That stays out. The fourth term is removed and added to 222 to come up with 316.7. Meanwhile, the other three terms have been repackaged into this perfect square. Let's check x squared, double the product here, so it'll be minus 51 doubled, which is 103.6, x, and then plus the square of 51.8, which is 2683. So we can see from this that x at the vertex is 51.8, and so that would be 52 days. One should wait for 52 days.